All right, so welcome to the Virginia Cyber Range weekly workshop, and we are going to continue talking about capture the flag challenges. So last week, so 2 weeks ago, we gave kind of the intro overview of CTFs, and we talked about general approaches to solving CTF challenges. And then last week, we talked about cryptography challenges. This week, we're going to start talking about networking challenges, and networking. Networking is really the bread and butter of cybersecurity, right? So we're going to spend a couple of weeks talking about networking challenges, and I'm going to use it as an opportunity to talk a little bit more about tools like Wireshark that you can use to analyze packets. We will dig into some different kinds of packet captures this week and next week. So we'll look at HTTP traffic, we'll look at FTP traffic, we will look at maybe some telnet traffic, and so the idea is that we get a feel for what the different protocols look like in a tool like Wireshark, and where to find interesting tidbits of information in those as you dig through the data in the packet capture. And I think today I'll probably also show how to capture packets, right? So folks have you know, in CTFs, usually we have folks pull down a PCAP file, packet capture file, and they'll analyze that packet capture file to find some interesting information. Today we're going to do a live packet capture using Wireshark, so you can see you know, so you can look at real-time network traffic, and we'll also take a look at how to, so you can sort of capture a bunch of traffic in Wireshark and then save the packet capture from Wireshark. But there are other ways to do it. There's a tool called TCP dump that you can use to capture packets, and it's sort of a more efficient approach, and you do it right at the command line, and it's it's a one-liner at the command line. You don't have to open up Wireshark. You don't have to have the overhead of having Wireshark running with all its graphical user interface and all that stuff. And I think if you have a high volume of packet traffic, you're less likely to lose packets if you're using something like TCP dump than if you're using Wireshark, because again, Wireshark has this overhead, and you know, it's got the graphic user interface, so it's got a bunch of overhead, and doing, you know, pushing the graphic user interface and capturing packets at the same time could potentially overload it a little bit, particularly on the you know, Cyber Range virtual machines. So if you use a command line tool like TCP dump, it's going to be doing really nothing but capturing packets. There's none of the overhead of the graphical user interface, so it's more likely to not miss packets. So it's possible for Wireshark to capture sort of most of the packets, but not all the packets. And again, it just depends on you know, how much bandwidth you know, how many packets are coming in and at what rate. But we'll do a hands-on demo of capturing packets and saving those packet capture files using a couple of different tools, and we'll do that perhaps today, maybe next week, depends on how far I get going through some other stuff related to Wireshark and networking challenges. Okay, but first we'll dive into some, if you want to play along today, there's the practice CTF that's up, so https://vacr.io/practice CTF. And so you might want to pause on this slide if you don't have this information. But if you go to the practice CTF in the upper right-hand corner, you can register if you don't already have an account here. If you do have an account, then you just log in. If you have an account and you forgot your password, then you can click the login button and then click the forgot password link, and it'll email you the password. It'll email you a password reset link. It won't email you the password, I hope. It's for today, it's great to have a Cyber Basics environment, because we're going to capture some packets between the Kali Linux VM and the and a web server in Cyber Basics. So most folks probably have a Cyber Basics environment provision for themselves and their students. If you don't have one, then you can join my class. And here's an invitation code. This invitation code is good through the 4th of March. So it's good for a week. If you are listening to this after that and you need access to this CyberRange course for this hands-on portion, then just send an email to support@virginiacyberrange.org, and we'll update the invitation code and send it to you. Okay. So weekly workshops each week, Tuesday at 1 p.m. for folks that like to listen live. Most folks, I think, listen after the fact, so we record these and we share them at https://virginiacyberrange.org. If you click on the community button, and then there's a link to weekly workshops. And if you're listening to this, you probably already found it. As always, if you have a particular topic in mind that you'd like to see us discuss, then you can send an email to contact@virginiacyberrange.org, or just send me an email, and we will add your request to the list of topics. A couple of news stories I'll sort of discuss just briefly. This is a news story I thought was very interesting, a little bit frightening. Happened this month at Amherst College, which is a private liberal arts college in Delaware, maybe. Don't recall exactly where it is, maybe Massachusetts. Anyway, Amherst College had a network outage, and this network outage lasted for 5 days, which is pretty incredible, I think. Network outage for 5 days. This affected their Wi-Fi, their email, Moodle, which is their learning management system. So kind of like Canvas, Moodle is an LMS that they were hosting themselves. It impacted employee payrolls, card scanning systems. So things like they have card scanners on the dorms, and in order to gain access to the dorm and then into the individual rooms. And when the card scanning system failed, and it was out for 2 weeks, or it was out for, for 5 days, they failed to open, right? So that means the doors were automatically unlocked. So when the card scanning system failed in the dorms and other buildings that were controlled by card scanners, they failed to open, so the doors were unlocked. And it wasn't until, so this happened originally on February the 11th. It wasn't until 2 or 3 days later when the university police came and locked the doors so that they weren't just open all the time. Of course, students generally gained access using a key card, not a key, so you can imagine the challenges. The college website was down for 5 days. Any content hosted on amherst.edu, including their career planning system called Handshake, this is a similar system that we use at Virginia Tech, that was down. And catastrophic failure, so the second bullet here, catastrophic failure of network infrastructure due to aging infrastructure and reduced IT staffing. So they said that, one of the news items I read said that network had been planned and installed roughly 20 years ago, and a bunch of the systems had been replaced about 10 years ago, and that was sort of the latest network upgrade to Amherst College was 10 years ago. So they had this aging infrastructure. They knew it was an aging infrastructure, and there were sort of tentative plans to start replacing portions of the infrastructure, and before they really got serious about doing that, they had this outage. And so this is interesting in a small private school that has a $50,000 annual tuition. That's not room and board, that's just tuition, and a $2.2 billion endowment. You'd think they'd do better at keeping the network up and running, right? So, of course, the big question is, how did this happen? And there's lots of, they're still digging in, I think, into how this happened, but it was a combination of a couple of hardware failures in the wrong places, along with some misconfigurations that caused what sometimes you refer to as packet storms. So you have a packet storm is essentially a denial of service attack on a local network that's generally not caused by malicious behavior, but it's caused by some misconfiguration in some system, and it causes a whole bunch of packets to get sent on like a broadcast to like a broadcast address, for example, and then a bunch of other systems that receive those broadcast messages, you know, send replies, and you get sort of this cycle of packets that just you can't, you know, until you figure out which system is misconfigured and take it off the network, then this packet storm is just going to continue to propagate. Usually those things are discovered within hours, sometimes minutes. 5 days is a long time. They brought in, you know, the whole IT staff was obviously working overtime. They brought in help from other close by EDU organizations. They brought in some like heavy hitters from Cisco and other vendors. And after 5 days, they got the network basically back up and running. The email system was still broken. In fact, they expected the email to be down for a total of about 2 weeks. So that 2 weeks would have been over just a few days ago. I don't know if they have their email back up or not, but this is pretty incredible that this kind of an outage would happen to a major university for this sort of a duration, and it doesn't appear to have any. It doesn't appear that it was because of any malicious act on anybody's part. It appears purely to be system misconfiguration in combination with at least one hardware failure, maybe a couple of hardware failures in this aging infrastructure. So the big question for the CIO, if he still has a job, and I don't say that lightly, you know, something like this could surely cause the CIO to have to find other work. This is a pretty significant event. How do you prepare and prevent this kind of thing? Well, you know, the biggest one is have a strategic plan for your IT infrastructure, and you know, there's some pretty important people at the top of the IT organization that are responsible for not only having a strategic plan for the IT infrastructure, but also for making the organizational leadership. And you know, this happens to be an EDU, but it could be a business or you know, any other thing. The IT leadership needs to make sure the organizational leadership understands the potential risk of these IT systems going down. I mean, you know, 30 years ago, this wouldn't be a big deal because we weren't so completely reliant on IT infrastructure, but that's just not the way it is anymore, right? You know, right now we're very much reliant on IT infrastructure. You know, if students can't get connected to the Wi-Fi, you know, they can't connect to the network. If their learning management systems are down, then it's much more difficult for the professor to communicate with them. If the network's down, I mean, I keep all my you know, PowerPoint slides and all my resources. You know, they're not on any local system anywhere. They're all somewhere in the network, and for me to get access to them, I have to have network access. So faculty can't prepare materials for class. I mean, this is pretty serious, and probably the most serious is where is it here? The employee payroll, right? Employee payroll was affected for 5 days. So if there was if a pay period ended during that time and people were supposed to get paid and they didn't, there's some serious implications that could come out of that are not just people being inconvenienced. I mean, there are you know, auditors will come in and start auditing your payroll, and I mean, there's all kinds of things that'll happen. The unions will get involved because you can't just not pay people, right? There's got to be a strategic planning effort and a serious IT risk assessment effort to understand what the potential risks are to a network, and the risks aren't always malicious intent, right? So a lot of IT risk assessment is talking about you know, how somebody might hack into a network, but more important and more likely to be a problem is component failures due to age or you know, misconfiguration or whatever. So that's regularly updated IT risk assessment is critical. And then, You also have to have a continuity of operations plan, right? A COOP. So what that says is, okay, if these systems go down, what's the backup, right? If the payroll system goes down, you know, if the network goes down, how do we make payroll? If Wi-Fi goes down, how do we connect students to the network, et cetera, et cetera. So you have to be able to continue operations in the face of technical failures, and so having a solid continuity of operation plan is important for situations just like this. And of course, there's also a business impact analysis that needs to be done that is all part of the strategic planning effort that says, you know, what are the really bad things that could happen that would negatively impact our business. And in this case, of course, the business is a university, and so what needs to be, you know, what do we need to do? What needs to be redundant? What can we do to prevent the negative business impact of something like this? And so you can imagine, you know, part of the problem at Amherst College was that almost all of their critical systems were hosted locally. So their email was local in their data center. Their Moodle is an open source learning management system. They hosted it locally. Everything was hosted locally. They hadn't pushed anything to the cloud. And if they had pushed things to the cloud, then if the network was up, then those cloud services would have been available at least. Email, you know, moving email to a third party in the cloud, you know, that would have at least kept email up for people who were able to access it from some location other than the university network. So like for people on their cell phones using the cellular infrastructure, they at least would have been able to send and receive emails. So anyway, this is a certainly an interesting story and sort of a cautionary tale for EDUs across the country. Okay, this story I just thought was kind of a joke. Nike shoes, right? So Nike is now selling self-lacing sneakers, and apparently there was an Android update that caused the Nike sneaker app to fail, and so they won't lace themselves anymore. And this is on this Sputnik News. This is actually in several news sites, but I saw it on this one. So Nike smart self-lacing sneakers stopped working days after launch due to app. Here's the quote, right? App won't pair with my left shoe, reads one such reviewer. Paired with sneakers right after unboxing, then completely crashed after the last update. Another customer wrote, same errors as others, can't connect to the left shoe, but the phone shows that it's paired. Lots of calls about this already, yada, yada, yada. So, yeah, I don't know what to say about this, other than it's a bad week for Nike, right? If you watch the Duke versus UNC basketball game last week, when in the first 30 seconds of the game, Duke's key player Zion Williamson, you know, stepped on the ground and his Nike shoe basically split in half, and his foot came out through the bottom of the sole. Not a great week for Nike from a PR standpoint. Okay, and then this is the last news story, I promise. This is a new phishing attack, right? So phishing attacks get better all the time, you know, more cleverly disguised. So this is a new phishing attack that even most vigilant users could fall for. And if you look at this box, this image on the left-hand side, this is a pop-up that you see sometimes. In fact, the Virginia Cyber Range uses these kinds of pop-ups, right? When you log into the Virginia Cyber Range, if you click Facebook as your OpenID provider, then you're going to get a pop-up that looks just like this. It says, please enter your Facebook credentials. You enter them, and now you're logged into the Virginia Cyber Range, if that's what you used to log in when you first associated your Cyber Range account with an OpenID provider. So this attack, phishing attack, uses a pop-up that looks identical to the real pop-up. And I'm going to show a video here. So bear with me while I pull up my YouTube. So this is a website. It says log in with Facebook to access the article, and it has a click. So so again, this is, you see this on some websites that allow you to use an OpenID provider to gain access to a particular resource. So if, you know, when you're doing this, you're logging into Facebook and Facebook is passing your credentials on to the, in this case, it's a news website, but so the news website is allowing Facebook credentials to be used to log into their site. And this one happens to be malicious, right? So this is a website that, a supposed news website that is going to ask for Facebook credentials, but we'll take a look at the video here. I may pause it a couple of times. So the victim visits a web page that looks legitimate. In this case, a news website. The victim is asked to log in using Facebook before being able to read the article. Okay, so far so good, right? So the user clicks on the button and they get this Facebook. So the Facebook login pop-up appears in order to allow the user to log in using Facebook. So what would they do? They would put in their Facebook credentials, username and password. User fills her credentials to authenticate to Facebook. Okay, so username, password, and then login, boom. And so this is a demo, proof of concept, right? So basically they took this malicious capability and they made a local app where they could just do a demo of it. And so the demo, when you put in your username and password, it just pops up this box that spits that information back to you. Of course, what the malicious owner of the website would do is they would just store that information and then let you through to the to the news articles, and now they have your Facebook username and password that they could use later. They could also do this with Google or with Microsoft. Those are other OpenID providers. So if you need to look here, credentials are stolen by the malicious page. In this case, whoops, let me go back just a bit. So credentials are stolen by the malicious page. I can get this thing to stop. Wow. All right, stopped it. Credentials are stolen by the malicious page. In this case, displayed as a pop-up. Facebook pop-up looks legitimate and is extremely difficult to spot as a fake. Okay, so the pop-up is fake, but it's hard to spot. To protect yourself from phishing, you're generally taught to check that the URL is valid, that HTTPS is enabled. In this case, you need to make sure the pop-up is actually a legitimate pop-up, not an inline HTML block. So basically, what they do is, you know, this pop-up is it's not a fake. I mean, it's a fake pop-up. It's actually a pop-up, but it's part of the page. So the way you would test this, and you can see by what this user is doing here, he's dragging the pop-up around, and the pop-up is part of the page. So it when you try to drag it off the browser, the pop-up sort of disappears in the it sort of disappears on the when it goes past the edge. Now, if this is a real pop-up, you can move that thing anywhere and it would act like a completely separate browser window. But in this case, it's not a separate browser window, it's part of the page. So this is a pretty clever attack, I think. Again, these phishing attacks are getting more and more clever over time. And as users get more savvy, the criminals who make the phishing pages get savvy right along with them. Okay, enough of the news. Now I'm back to my slides. Okay, this week, networking challenges. Next week, more networking challenges. And if you want to play along, here's the details. So go ahead and pause this page and get what details you need, because I'm going to close this presentation and I'm going to open my other presentation. Full screen. All right. Actually, the other thing I'm going to do, I'm going to open, before I dive into my slides, I'm going to open my my CyberRange account. Bear with me for a second. So I'm going to go to console.virginiacyberrange.net. logging with Google. And again, this is a, this is a whole separate browser window. So if I were to make my, yeah, see, so this, I can take off the, it's a whole separate browser window. This is the expected behavior. But if I was to drag this off the page and instead of leaving the browser, it just sort of disappeared under the edge of the browser, then it's likely a fake. All right, but I'm gonna use my Google account, log in to the Cyber Range. Workshop, Cyber Basics. I'm going to start. Okay, so now back to the slides. All right, so we talked about CTFs last time, right? So I'm going to jump ahead. Overview, general tips. We talked about crypto challenges. We did some crypto challenges last week. And gosh, this thing is going crazy on me. All right, I'm going to stop pushing buttons. All right, we're going to talk about networking challenges. So networking challenges generally have a packet analysis component, right? So you either are given a packet capture as part of the challenge, or sometimes there will be not live network traffic between some endpoints, and the exercise will involve intercepting traffic between endpoints, and normally you only do that if there's a wireless network, because if you know about switched hardline networks, you'll know that it's generally not possible. Well, it's extremely difficult to eavesdrop on all switched network traffic. It's hard to see the traffic of other endpoints. It's easy to see your own traffic. It's hard to see the traffic of other endpoints. But in wireless networks, since wireless traffic is broadcast to everybody within earshot, it's easy to essentially eavesdrop on other endpoints' wireless communication if you're listening on the same channel and the same wireless network as them. So sometimes network challenges will have you listening to live packet captures. A lot of times it's just most of the time it's just a packet capture file, and you have to download that file and do something to find a flag. And sometimes you have to like carve images out of the files, right? So you can imagine if network traffic might be the transfer of files between two network endpoints, and so you have to be able to take a packet capture file, which is just a bunch of TCP packets going between endpoints, and be able to identify files that are being transferred between those endpoints, and then pull those files out and turn them back into image files or Word documents or whatever they are. So that takes a little bit of particularly special knowledge, and we'll talk about how to do that. It's really not it's not super difficult. Used to be more difficult than it is, but now tools like Wireshark make it pretty easy to do those kinds of things. So the tool that I'll recommend for most networking challenges is Wireshark. And if folks are not familiar with Wireshark, it's a nice GUI tool, right? So it has a nice graphical user interface, and it's used for analyzing network traffic. And once you learn the basics of Wireshark, then it's extremely powerful tool, and you can do lots of interesting things with it. And we're going to talk about some of the basic features of Wireshark today, and then next week could probably talk about some more of the advanced features that you might need when you're attacking these kinds of challenges. Cool thing about Wireshark is it's available for Windows, Mac, and Linux. It's, I should say that it's free. So you can download it off the Wireshark website for free. And it's updated frequently. It's well maintained, and there are new versions of it that come out all the time. Other great tools are a tool called TCP dump and WinDump. So TCP dump is a Linux command line tool for examining network traffic. It's very powerful, but it's very lean, right? It's you know, as is typical of Linux command line tools, you have to know how to use it. Once you know how to use it, it's a great tool, easy to use. Has lots of great features, but it's you know, it's not point and click. You have to do things at the command line, and so it's the learning curve is a little bit steeper than something like Wireshark. But we're going to take a little bit take a look at a little bit of TCP dump either this week or next week. Depends on, again, how far I get today. And then there's another tool called ngrep, and this is something that's not widely known. This is ngrep stands for network grep, and grep is a tool for finding words in files, right? So you can use grep to examine a file and find particular words in it, and network grep does the same thing, but it doesn't look at, you know, so grep generally interacts with like text files at the command line, and you know, in Linux, everything's a file. That's kind of the mantra of Linux. Everything's a file. Even if it's not a file, it's a file. And you know, config files and most of the files in Linux are text based. So if you need to find a particular word or phrase in a Linux text file, then you use the grep tool to do that. Grep, it's an acronym. I think it stands for General Regular Expression Processor, perhaps. Anyway, so ngrep is a network grep, so it does the same thing that grep does, but instead of doing it to text files, it does it to packet capture files. So pretty useful tool. Sometimes you can just ngrep the word flag in a, you know, you could say at the command line, you could say something like ngrep flag equals, and then the file name. Or flag curly bracket, right? And lots of CTFs use a particular representation of flags, right? The flags will always say either flag equals or flag curly bracket. So if you can use ngrep on the PCAP file, sometimes the flag just falls out right away. Now in the CTFs that we create at the Virginia Cyber Range, we don't use that convention all the time. Sometimes the flags are of the form flag curly bracket and then the flag within the curly brackets, but you know, that's a little bit too easy oftentimes. So we don't use that convention all the time, because in the real world, when you're doing some forensic analysis, you know, the malicious payload is not going to be clearly labeled with flag equals. Okay, sorry, I went back one. So we're going to take a look at Wireshark hands-on here in a second, but Wireshark uses this notion of display filters that let you so if you're listening, if you're going to do a packet capture, and again, we're going to do this in a second, we'll do it live on the Virginia Cyber Range network. If you do a packet capture and you're listening to traffic, you could, you know, in just a couple of minutes, you could capture thousands of packets. And in order to drill down on the particular packets that you want to see, the way to do that is to use packet filters. And you enter your filters in this box right here. And right now the box is green. the box is different colors depending on what's in it, right? So if you have a properly formed display filter, so the syntax of the display filter is correct, then this box is going to be green. If you have an improperly formed display filter, it's going to be red or yellow. So red is basically the syntax of this is completely wrong and it won't do anything at all that's useful. Yellow means I can interpret this, but it could be, but it's a kind of a warning that tells you this may not be quite what you're trying to do, right? It's malformed in some way. So you put your packet filter in the text box. There's an expression button that you can use to help create filters. So that's right here. I don't usually use this, but it's a thing that you can use. So if you click on, well, we'll look at it in a minute, but you can click on expression and then you can sort of search for what you might be looking for. But the best way to do it once you're kind of used to Wireshark is you just type the thing in the box here. So once you have your filter in place and you have a green box, then you either hit enter or you click the apply button, which is the little arrow. And then to clear your filter, you click the X and that'll clear the filter. So some display filters, the example here says ip.dst equals 10.3.0.20. So ip.dst equals 10.3.0.20. This means IP packets going to, and then this is the IP address, right? So IP packets going to this IP address and TCP.port 80. So packets in which the destination address is this and the TCP port is 80. So that means that it's HTTP traffic going towards that particular destination IP. That's what that capture filter is doing. So if you want to look at packets from a particular IP address, then you say ip.source or src, ip.src. You always use double equals, and then you put the IP address. Packets to and from port 80. So tcp.port equals 80. You can also do tcp.source, I believe, and tcp.dest, I think. So packets to and from port 80, tcp.port double equals 80, from 10.10.3.2 to 10.10.3.40, ip.source equals, and then you put in the IP address, and ip.destination equals this. So if you're just looking for packets in one direction between two hosts, you can use that kind of a filter. If you want packets to or from a particular IP address on a particular port, then you can say ip.adder, ip.address equals the IP address and TCP port equals 443. So it's going to be HTTPS traffic to or from this particular IP address. So pretty powerful tool. And I'm going to jump into my virtual machine so that I can do some of this. Well, let's see, let me pull up my slide again here. I'll close this one. All right, so if you're listening to this offline, then you might want to screenshot this this slide, because I'm going to go from this slide back to the Virginia Cyber Range. But what I'm going to do is we're going to take a little exploration of Wireshark, and for this little exploration of Wireshark, what we're going to do is we're going to capture some HTTP traffic. and then we're going to look at that traffic. So we're going to log into our Virginia Cyber Range account and open the Cyber Basics 2018 environment. I've already done that, so my thing's all ready to go. And then we're going to start Wireshark, and we have to start it we have to use sudo to start Wireshark in this case, and that's because we are going to promiscuously capture network traffic between our host and other hosts. And in order to promiscuously capture network traffic, you have to, and what promiscuous means is that that Wireshark is going to capture every packet that wireless network adapter sees. And as a non-root user, you can't do that. As a non-root user, you can only capture packets that are destined to a particular process that's running by that particular user. So if I am the user student, I can see some subset of all the network traffic that is playing on a particular network. If I'm listening on promiscuously as the root user, then I can see all the traffic that network interface sees. So there's a difference between those two things, right? A user is only going to see a subset of the traffic that the network adapter sees. The root user is going to be able to observe all the traffic, and that's even more important on a wireless network. If you're on a wireless network, the root user is going to see all the network traffic that's on the same network that the device is connected to. And so normally the TCP/IP software in the operating system is going to filter out a bunch of that network traffic. So a user at the user level, you'd never see most of it because your system is, because you're operating, because if those packets aren't destined for your particular computer, then there's no reason for you to see that. But it's still there. The network adapter still sees it. It just doesn't pass it up to the user interface unless you are listening in this thing called promiscuous mode, which means that you take all the network traffic that the network card sees and you pass it up to the user interface and let the user interact with it. And you can only do this promiscuous mode thing if you're root. So you must be root. The way you do that is you run Wireshark using sudo. Remember, sudo means super user do, and then the name of the program. And I use an ampersand just so Wireshark, I'm not even going to explain it, but ampersand gives you your prompt back because it runs Wireshark in what's called background mode. And then, so we're going to get Wireshark started up, then we're going to capture traffic on the ETH0 interface. We're going to open a web browser. We're going to browse to http://dvwa.example.com, and then we're going to stop the packet capture. And that's just going to give us some number of packets that we can examine and answer some of the questions on the bottom half of the slide. And this is a great exercise to do with your students. So I'm going to open my terminal. I'm going to say sudo Wireshark. Wireshark comes up. Oh, and it's going to give me an error. And you can just click through the error. It's telling you that what you're doing is dangerous, and the dangerous thing is you're running Wireshark as the root user. So we're going to ignore that warning. Okay, and so now I'm going to capture traffic on ETH0, and this is kind of cool that Wireshark shows you which interfaces that there's actually traffic on. So it shows this little graph. So on ETH0, there's a little bit of traffic, and then the any interface that captures all traffic on all interfaces. So if I had if I had multiple network interfaces on this thing, for example, I would see all the traffic there. But I only care about ETH0. That's my wireless. That's my not wireless. That's my virtual network interface card that connects this virtual machine to the rest of the Virginia Cyber Range network. So I'm going to click the little fin button. That's going to start my packet capture. And you can see I'm not doing anything, and look at all this network traffic, right? So there's lots of network traffic going on all the time. Now I'm going to pull up my web browser. And I'm going to go to http://dvwa.example.com. Okay, so I got a web page, and now I'm going to stop my packet capture. Okay, so I've got a whole bunch of network traffic here that I've captured, and here it is, right? I mean, there's a ton of packets. Somewhere here, I think it tells me how many packets I've yanked. Packets 24,966. So in the course of maybe less than a minute of packet capture, I captured almost 25,000 packets. So lots of stuff. Okay, so how do I find? Well, let me go back to my slides real quick. Okay, so so can you find so I'm on the question section. Can you find the TCP three-way handshake with the web server? So remember when a TCP connection is made, there's this three-way handshake. So the client machine, which is my Virginia Cyber Range Kali Linux machine, it's going to reach out to the server, which is the DVWA web server in my Cyber Basics environment. It's going to send what's called a SYN packet over TCP, synchronize, and then the web server is going to send back a synchronized packet, and an acknowledgement packet. So that's part 2 of the three-way handshake. And then my client is now going to send back an acknowledgement packet. So you have this three-way handshake for the transmission control protocol. And what that does is it sets up this virtual connection between my client, which is the web browser, and the web server that's running at dvwa.example.com. So that's the three-way handshake, and we want to be able to identify this three-way handshake in the packet traffic. And to do this, I'm going to use this packet filter. I'm going to say tcp.port == 80, and remember what that's going to do is that's going to show all traffic, all HTTP traffic going to and from, or all traffic on TCP port 80 going between, I'm sorry, it's going to show all of the traffic on TCP port 80 on in this whole packet capture. And so any packets that this network interface was able to observe that was going to or from port 80, we're going to get that in our filtered list of packets. So I'm going to say tcp.port. Oh, I mentioned earlier that there's this expression button. So this lets you like dig through all the different protocols that Wireshark recognizes, which look at this. I mean, these are all network protocols that that Wireshark recognizes, and there are thousands of these, right? So networking is pretty complicated field. But if I was to find TCP in here, TCP, then I could say, well, yeah, so, okay, now I get the list of, within TCP, I can say, okay, TCP dot whatever, and I'm not going to dig through this list, but this filtering language you can see is pretty darn robust. I'm just going to type in tcp.port == 80. And what you'll find in Wireshark is that unless you're looking for some very specific things, most of your packet filters are going to be either specifying source or destination IP addresses or specifying source or destination ports. Sometimes you're going to want to use the contains filter because you're going to maybe look for specific strings inside packets, but most of it's going to be IP addresses or TCP ports. Okay, so so I got more here than I expected, actually. So here is here's a three-way handshake between 10.1.112.25 and 10.1.97.126. So here's the SYN. So if I look down here at TCP, flags, SYN is a flag in the TCP header. So you see that the only packet or the only flag that's set here is the SYN flag. So what I'm looking at in the bottom is I'm looking at the protocol hierarchy, and if you recall, if you look at the TCP/IP protocol stack, at the very bottom layer you have the hardware layer, right? So this is this is bits going over a packet. So physical layer is at the very bottom, and Wireshark just happens to show these physical layer at the top, and then the next thing down it sees is the Ethernet. So that's the medium access control layer of the TCP/IP protocol stack. Next, you have the IP layer. So this shows the source and destination IP addresses, and then so here's source 10.1.112.25, destination 10.1.97.126, and then you have the TCP protocol. And once we get to the actual HTTP traffic, then on top of this TCP traffic, you're going to see the HTTP traffic. So we'll see that in a minute. But transmission control protocol, here's our SYN. So we have the SYN, you can see it up here quite easily, SYN, then a SYNAC, and then an ACK, and that's the TCP three-way handshake. And it actually turns out that, I guess when I opened the browser, this web interaction happened because there was a call out to, so this is the HTTP traffic, get detectportal.firefox.com, and it went and grabbed that, but that's not, so this is HTTP traffic. This is not the HTTP traffic I'm looking for, right? Because what I'm looking for is the, there's a whole bunch of, I guess I should have closed all my windows when I did this, because what the web browser will do is if there's any open windows, it's going to reach out and try to grab packets. Anyway, so here's a TCP three-way handshake, SYN, SYNAC, and ACK, and there's quite a bit of HTTP traffic and HTTPS traffic going on here. So so one way you can see the entire HTTP interaction is you can go to follow and then TCP stream. And this shows this get to detectportal.firefox.com. Here's the return. Here's the return from the. So the red is the client. So this is the web browser reaching out to a particular web page. The blue is the response from the web server. And so then the red, my browser makes another request, and the blue is the response, and the red is another request, etc. And if you look through these, you see a lot more information about what's going on in this interaction. But what I want to find is, I want to find my DVWA connection. So I'm going to clear this web filter. Let me try tcp.port equals 80 and contains dvwa.example. Oh, my and. Why is that not working? TCP contains DVWA. There we go. Okay, so so to find the particular interaction with the DVWA, you know, if I want to look at that particular HTTP interaction, then I said TCP contains DVWA. And here I get some HTTP traffic, so I can right click and, well, we won't right click yet. So down at the bottom here, I can see my GET request, right? So when a web browser reaches out to a web server for a web page, it does this HTTP GET request. So here it's doing a GET request using the HTTP 1.1 protocol, and the host it's reaching out to is dvwa.example.com. Remember, that's what we typed in the browser. And so now if I look at my questions on my slide, so I just switched back to my slide. So we found a TCP three-way handshake, right? What is your IP address? What is your so what I'm looking for is my IP address of my Kali Linux virtual machine. And there's a couple ways I could do this, right? I'm going to pull it out of Wireshark, but I could also, we know that we can go to the command line and we can use the ifconfig command to find our IP address. So what we'll do is we'll look for it in the Wireshark, and then we will confirm it at the command line. So here's the GET request that I was just looking at, right? Get HTTP 1.1, and then it has the host dvwa.example.com. So that's a packet that's being sent from my Kali Linux virtual machine to the virtual machine that's running the DVWA server. And so if I look at that, I have that packet highlighted up at the top here. And so I can see that the source address is 10.1.112.25. Source 10.1.112.25. Destination is 10.1.125.25. Right, so my source address is 10.1.112.25. 10.1.112.25. 10.1.112.25. What is the IP address of the web server? 10.1.125.25. So now if I go back to my Kali Linux VM, I can say ifconfig, and my IP address is in fact 10.1.112.25. It's right there, right? So I just confirmed the answer that I found in Wireshark. Okay, what is the operating system? What operating system is the web server using? Oh, operating system of the web server. How am I supposed to figure that out, right? I can't log on to the web server. I can only interact with it with this web traffic. Well, let's see. So here is my, I'm going to move this up a little bit. Here is my GET request. And remember, that's the application layer protocol. So in this case, the Wireshark is showing the TCP IP protocol stack sort of upside down. So you have physical, then the MAC layer, and then the IP layer, then the transport layer, and then on the top, and in this case on the bottom, you have the application layer, which in this case is HTTP, Hypertext Transfer Protocol. And this is my GET request. And when you make a GET request, the HTTP protocol has a bunch of header fields in it, and those header fields send a bunch of information to the web server that the web server uses to package the response that it sends back, right? And so the first one is what's called the user agent string. And so this says, this is my browser saying, I am a Mozilla 5.0 compliant browser, and I'm a Linux x86_64. So that means it's a 64-bit Linux, it's 64-bit architecture, Linux operating system. And then it says the browser is Firefox version 52.0. So that tells the server a whole bunch of interesting information about my system and my browser. And if you've ever gone to a website, for example, and it seems to know that you're on a Mac or you're on a Windows machine, it's not just assuming that. It knows that because your browser tells it that when you connect to it. So it's not magic. It's actually the way the protocol is designed to work. Okay, so but remember, we're trying to get the web server. We're trying to get information about the web server, not the client. So here's the response. Whoops. Okay, so so I'm only seeing one half of the transaction here because I'm still using this contains DVWA filter. So what I'm going to do is I'm going to say TCP dot. I'm going to say IP.address equals 10.1.125.25 and TCP.port equals 80. So I just put in a capture filter here. IP address equals 10.1.125.25. Remember, that's the web server. That's the DVWA web server. And TCP.port equals 80. So this is HTTP traffic between my host and that target host. And so here's that GET request we were just looking at. Here's this three-way handshake, SYN, SYNAC, ACK. There's my GET request. Now here's the response from the server. So it's from 10.1.125.25 to 10.1.112.25, and it's an HTTP packet. And so if I look at the header data, I can see that the server is running Ubuntu, and so it's Linux, Ubuntu Linux, and I can see that the server software is Apache 2.4.7. So that actually is useful information if you're an attacker who's going to attack a website. If you know the operating system and patch level of the OS, and if you know the version of the web server software, then you can look in your library of exploits for exploits that to which those particular pieces of software might be vulnerable. So sometimes web hosts, people who administer web servers, sometimes they'll change the configuration of their web server to actually hide information like the version of the web server software from users because they don't want somebody malicious to be able to identify a bunch of interesting information about their particular web server software. Okay, so what is the operating system the web server using? It's Linux. What web server software is in use? That's Apache. Compare content return page to Wireshark page source. Oh yeah, so now we can see if we drill into this a little bit. We can see the actual page that gets downloaded. That's another GET request. You got to dig through the packets a little bit, but eventually what you'll see is the portable network graphics, right? So what happens when a web page loads is it first the HTML file loads, and then if there's any images that are embedded in the HTML or in the web page, then the web browser is going to make a request for each one of those individual things. And so here is this is cascading style sheet, right? And I'm trying to find the HTML file. Where the heck is it? Text HTML. Oh, here it is. Okay, so here's the actual HTML. And remember, HTML is the language of the web. And if I go back to the web browser and I click on developer page source, I can see here it is, right? Doc type HTML public. Then it has HTML XMLNS equals www.w3.org, yada, yada, yada. So it's telling it this is the XML type that I use. And then it's got the head and then the body. And if I go back to Wireshark, if I go to Wireshark and I look at, here's that same thing, but instead of looking at it in the web browser, I'm looking at it in the HTTP payload of the packet that came back from the web server. So here I can see that text file data in a packet capture. And so if I wanted to, I could strip that data out and I could put it into a text file. And now I have a recreation of that file that got sent over the network. And I can do that from not from an actual file, but from a packet capture that is observing network traffic between two endpoints. Okay, I'm going to stop there. That was a more of a Wireshark intro than a CTF discussion, but this is all important background that you're going to need in order to use Wireshark effectively to solve networking CTF challenges. So next week we will dive into some actual CTF challenges, and we'll use Wireshark to do the analysis of those packet capture files. All right, so thanks for listening, and we'll see you all next time. So thanks.